Okay, today in IM2, we're going to start on Chapter 10. A circle is the set of all points in a plane that are equidistant from a given point called the center. A circle with a center P is called circle P, and it can be written as, you can see this little symbol right here. Okay, so there's circle P, and here's a whole bunch of circles. All right, the center of a circle is a point inside the circle that is equidistant from every point. Think back to when we made a circle with a compass. Okay, when we had our pencils and we just went around and make a circle. Since this is the same every time, that's what creates the radius, and mine is pretty terrible, but it shows you how it would be equidistant because this distance stays the same. So your pencil is constantly at the same distance from that center point. Okay? The radius of a circle is the line segment from a point on the circle to the center. So what is meant by on the circle? Anything that is on here, like this. Point C is on the circle, point D is on the circle, point B and point B and point E are on the circle. This is a radius, okay, because it is from the point on the circle to the center. Same with this, and this part here. Those are all radii, okay? All right, line segments that intersect circles. A segment whose endpoints are the center and any point on the circle is a radius. We just went over that. Okay, a chord is a segment whose endpoints are on the circle. Okay, notice it stops right here. A diameter is a chord that contains the center of the circle. So always a diameter is a chord, but a chord is only a diameter if it goes through the center. A secant is a line that intersects the circle in 2 points. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point, called the point of tangency. The tangent ray AB and the tangent segment AB are also called tangents. So if you have just a short segment, you know, like that, then that's a tangent. Or you can have this as a tangent, or even a ray as a tangent. Okay. All right, so you're going to look at this, and they want you to name all the things. So this is in your journal, and if you want to, you can push pause and then see if you got these right, but you're going to use the names that are actually on the picture. Okay, so we're going to talk about radiuses, AB, AF, AD. Those are the only ones on this picture. A chord. So the chord is ED, segment ED, okay? DF, which is the diameter, and also EC. EC is the traditional chord. ED is part of the segment of a secant. Okay, so ED is my secant because it intersects in 2 places, but the segment ED is also a chord. Name a diameter. That would be FD. That's the only one they gave us. Name a tangent. So that would be line B. Okay? We don't have another name for it. Name a point of tangency. B is a point of tangency. Okay? How'd you do? Ask yourself, what do you need to understand better? Okay, so coplanar circles and common tangents. In a plane, 2 circles can intersect in 2 points. No points, so here we have no points of intersection, or 1 point, where they share a point of tangency, okay? Coplanar circles that have a common center, like this, are called concentric circles. A line or a segment that is tangent to 2 coplanar circles is called a common tangent. Okay, a common internal tangent intersects the segment that joins the centers of the 2 circles. A common external tangent does not intersect the segment that joins the centers of the 2 circles. So this would be an internal tangent, and this would be an external tangent. Okay, this is from your journal on page 315. So tell how many common tangents the circles have and draw them. So you can try to think of what all the tangents they have in common are, but keep in mind, if I have a tangent over here, it's not going to hit that other one. So here's a picture of the common tangents, And you can see that it hits both of them, so there's actually only 2. And then it wants you to tell whether each common tangent identified is internal or external. And they are both external, okay, because they don't have anything to do with the centers. Okay, so a tangent line to a circle theorem says that in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. Okay, so look at that carefully. So when we have a tangent, if we draw a perpendicular line, a perpendicular radius to that point, it is a tangent. Okay? So keep that in mind. The external tangent congruence theorem is if you have tangent segments from a common external point and they go tangent to the same circle, they are congruent. So important things to remember. Okay? Okay, so verifying a tangent to a circle. Is ST, that's this line here, tangent to circle P? So how do we prove that? Well, we know that if it's tangent, this will be a right angle. So we would do the Pythagorean theorem. So 12 squared plus 35 squared, make sure you know which one is your hypothesis, equals 37 squared. And then we check 144 plus 1225 equals 1369, and it checks out, so the answer is yes. Okay, in your journal on page 315, we have problems 9 and 10. They're telling you that point D is a point of tangency. Since that is given, we also know that this is a right angle. They want you to find BD. So think about how you would do that. Okay, I would do the Pythagorean theorem again. BD squared, remember, make sure you know which one's your hypothesis. BD squared plus 5.5 squared equals 10 squared. And then I'm going to go BD squared minus plus 30.25 equals 100. Subtract 30.25 from each side. I get BD squared equals 69.75. Take the square root of both sides, and BD is approximately 8.4. Okay? Then it says point C is also a point of tangency, and if BC equals 4x plus 6, find the value of x to the nearest tenth. Well, we know that since they have the common external point, that these are going to be equal. And we already know that this is 8.4. So we're going to go 4x plus 6 equals 8.4. 4x equals 2.4. So x equals 0.6. So x equals 0.6. Okay? And then you could double check it. This would be 2.4 plus 6, which is 8.4, and it works. All right, so using properties of tangents, RS is tangent to circle C at S. Okay, so right there. So we know that this radius is going to be like that. And RT is tangent to circle C at T. So there we go. We have another right angle. Find the value of x. So the cool thing is we know that this is equal to this. We don't know what it is, but we know that it's equal. These are all things you have to think about. We also know, since they have a common external point, these two are congruent. So we're just going to say RS equals RT, and then we're going to go 28 equals 3x plus 4, 24 equals 3x, so x equals 8. So there's the value of 8, and I did want to say these are equal because they're both radii of the same circle. Okay, so that's why those are equal. If I didn't say that, go back and check this. 3 times 8 is 24, plus 4 equals 28, and we know it's right. Okay? All right, don't think that all problems will be easy to do in your head. You need to make sure and show your work so that when you get to the more difficult problems, you know how to do it. And speaking of difficult problems, here's a good one for you. So using structure, each side of a quadrilateral is tangent TVW WX is tangent to circle Y. Find the perimeter of the quadrilateral. So first thing that you're going to do is you're going to think, okay? This is a common external point. So it said all the sides are tangent. So we know that this, okay, these two distances are equal. So this is 3.3. And then I can go 4.5 minus 3.3 is 1.2. So this is 1.2. And that is verified right there. We also know that these are equal. So we know that this, and we know that this is 3.1. So we subtract 3.1 from 8.3. We get 5.2. So that means this is 5.2, which means this is 5.2. And then we've got all of the sides, so we're going to add everything up. And so that would be, if you add each of the sections, so this side is 6.4. This side is 4.5. They gave us that one. The next side is 6.4. And the last side is 8.3 because they gave that to us. And so the final answer is 25.6. So that external tangent rule where they're equal if they have the same common rule point really helps with this kind of a problem. Alrighty, so that gets us through to your exit ticket. And you're going to be solving these. So the answer to the first one is yes or no. The answer to number 2 is find the radius. 3 is find x. 4 is find x. So good luck with that. Take care.